Now if you have a resistor inductor circuit, or you can say series RL circuit, and we need to find I of t for this. The switch is closed at time t is equal to 0. So initially the switch is closed at t is equal to 0, and L is initially unenergized. That means there is no current flowing through the inductor. So we can say for t is equal to 0 minus I of t will be 0. Then t is equal to 0 plus, again there is no current flowing through this, so I of 0 plus will also be 0. So directly we can start for t greater than 0. So analysis starts from t greater than 0. We can say when you apply KVL, the switch will be closed in this case, and the diagram will be like this. At t greater than 0, the switch is closed, inductor, resistor, voltage source, I of t. So V minus I of t into R minus L di by dt is equal to 0. So writing in the standard form, you will get it as di by dt plus I into R by L is equal to V by L. That is rearranging these terms. So we'll get P as R by L and Q as V by L. Integrating factor e raised to R by L t. So I of t straight away we can write, rather than doing this straight away, I of t is q by p, that is v by l upon r by l e raised to minus p plus c e raised to, we can write it in the other form also. I can show you. I of t is equal to, which is our standard form, q by p plus c e raised to minus p into t. So straight away it will give you the equation, and you can then find the value of c at t is equal to 0 plus. We know it is 0. You know q and you know p. Substitute in this equation. So you will get q by p as v by r, as you have got here. So if we are solving by the shortcut method, this is the normal method where we find the integrating factor e raised to my pt, then we multiply e raised to pt on both the sides. So we'll get I of t raised to r by l t v by l, then integrating this plus c. So from this we find c at t is equal to 0. I have 0 plus is 0, so we can find c as minus v by r. The same thing can be done in this. I'll show it here. I of t q by p is v by r plus c e raised to minus p is r by l into t. At t is equal to 0, I of t is 0, so c will be minus v by r. So this is the shortcut to do this entire derivation. Rather than writing all the steps, straight away you can find I of t as v by r minus v by r e raised to minus r by lt. So this is the final equation what you will get in within 1 or 2 steps from this. This is again the lengthier method. One more method is there given in the book, so I can either use this or this to derive the final equation. So you can call this as OR, shortcut method, which you can use for solving the equations. So I of t is v by r minus v by r e raised to minus r by lt, where v by r is the steady state response or forced response or zero state response, whereas this is the transient or natural or zero input response. So these are the two responses. Steady state is when it is attaining a steady state condition. Transient is before attaining the steady state. So total response is steady state response plus the transient response. This is how we derive the responses for a series RL circuit.